Assalamu alaikum. This will be a short video. This is experiment 7 about the 51 arithmetic instructions. So we will combine the knowledge that we would have today or something that you have done in the lecture with the addressing modes that we have done before. So just briefly, I will go on some of the instructions. For example, here we have the addition, add with carry increment, subtract with borrow, decrement, multiply, and divide. I'm not going to go through all of them, but some of them, and you need to investigate the others, okay? The addition we already know, add a with something, so the result will be an a. This we have done many times. This is an example. We are putting this value into a, and then this adding this value into a, and then we might have carry or not, so you have to look at the carry, okay? And we did this before. Okay. So here is an example that you can look at. Always you can run on mine. I'm not going to do everything. So you have the mine, you can practice on your own. And here is the subtraction. I'm not going to talk about it. You should know it. Maybe you'll need it in the project, but this is what it is. A equal to a minus source minus the carry. Okay. So here is an example that you can look at. I will go to the multiplication. Now what we do here is we multiply a by b. So this is the instruction mul ab. So you have to have different values in a and b, and the multiplication will be like b is the high byte and a is the low byte. Now some of the mistakes that happens is that when you do in a loop, you want to multiply a number by, for example, number 2, and then after multiplication b will become 0. So you have every time to initialize b in order to multiply your number. Okay, this one also you can try it with different values in a and b and see the result. I suggest that you try mine for these simple instructions, just to give to have an idea of what happens when the higher byte is 0 or not. And then we have divide a b, and then we will do like this is a, this b, this will do the division. Of course, here we have either the quotient or the remainder. So the quotient is a and the remainder is b. Okay. We'll not look here or how to find the exact number of division, but this is what you're going to do. I'm going to give you some examples. Every section will have its own report. So just to give you an idea, this is experiment 7 that I have done before. Not this one, maybe similar one, where we have some numbers and we need to add them. Now I'm telling you here that you need to put the higher byte in R2 and the lower byte in R3. So we will have some numbers. So I'll just give you an example here. For example, let's say move a number 4 as okay, number 0 FE, and then add a with, for example, number 30. So let's see what will happen here. Okay, this is what I'm talking about when you are going to do some simple examples. So for example, this is the value of a now. Okay, it is this one. Now I'm going to add, see what happens. Now this number is less than the FE, which means that I'm sure that there is a carry. You can see it here. Huh? C5, when you decompose it, remember the last digit is actually the carry. And you can also check jump, if carry, jump. If there is no carry, you can use these two to do some operation. Okay. Yeah. What I want here, I'm telling you that I'm I'm telling you that I'm going to use R2. R2 is this one, huh? Just I would like to show you an example. Let me make this one 55. See, it is changing here. And this is R3. Remember, this is bank 0. So these are actually the same as the resistance. So if I use R2 as higher pi and R3 as lower pi, the result will be read in this way. Huh? So this is the addition, and this will be the higher byte, and this will be lower byte. It will be better to have it this way so that it's clear to you that this number is the higher byte. Okay. So I'll give you an example either to initialize some data or something saved, and then you need to add them. And in the second part, in here, uh, I will ask you to do program with 3 subroutines. Okay. Yani, if I come here, so here what he's doing is transfer data from ROM to RAM, for example, and add them, save the results somewhere, and then find the output. So the way to do it is this way. I'm just going to give you an example. A call transfer, for example, a call addition, and then the last one you can do it later. And then you can do short jump, $sign here like this. So what you can do is transfer and return, and then addition and return. Now, I gave you the backbone. There is another third one, or maybe I'll give you 2. Then you need to write your program here. Now, what is the advantage of this? In the project, it will be easier to look here to see what I'm doing. I know that this one is actually the transfer, so I can easily go to the transfer subroutine, or we call it in other languages function. We usually do functions so that I can use them again and again. So for example, I can say they call transfer. Okay. And here, do everything inside, even the initialization. In other situation, maybe we need to initialize, maybe we can do it inside, but for our experiment, do it this way. Now in the project, I'll give you, for example, 4 parts. So this is part 1, part 2, for example, addition, multiplication, whatever. So what you're going to do it this way: a call multiplication, a call addition, a call, for example, division, a call part 1, and then it will do the parts for you, and it will be easy for you to check, and easy for me also to read your code. Okay. So this will be very, very easy to do. You can have numbers. The way to check the result is to add them, and then check the result, check there, for example, sum and average. Okay. And then compare the result of the two. Like in this case, also, he's having some numbers and he wants you to find the number of factors of 36. So I'm going to change probably the number. So for example, 2 is a number of 36. So put the result into R5. For example, let's say I have only these. So how many factors do I have? So 2 is a factor, 3 is a factor, okay, 4 is a factor, 6 is a factor, 7 is not, 3 is repeated but also a factor. So I don't want you to count them like I have 2, 3, and 4, and 6. No. So this would be 1, 2, 3, 4, 5. So the result is 5 factors. Okay. Now I will think about the third or the fourth part, or probably give you 2 parts for each section. You need to look at your report for the section and try to solve it. You can do it before the lab, you can do it during the lab, and always anything that is required is the code, picture of the original data or the initialized data, and picture of the result, and also comment and explain why do you see such a value. Okay. So this will be a very short video. I will upload it, inshallah, try to solve the experiment before you come to the lab. Always, if you have a question, you can send me an email. We can meet online.